Hello and welcome to Rocket Launches Astrophysics and Space Talk, brought to you by Borderless Labs, bringing the world together through STEAM. My name's Mac, and I have with me SpaceMike and Athena from tomorrow, youtube.com/TMRO. SpaceMike, you also have your own YouTube channel. What's it called?
That's right. You can check me out at youtube.com/SpaceMike, or even check out my old content at youtube.com/EpicFutureSpace.
And Athena, where can we find you online?
You can find me at Astro Athens. That is also astroathens.com, youtube.com/Astro Athens, and of course all of Twitter, Instagram, any social media. I am Astro Athens across the board.
Okay, and I also call her the model astronomer, and we'll get to that later. Wow, you guys, what a 2018 in terms of space launches, astrophysics. Incredible.
Seriously.
Yeah, there were so many good things that happened. It even ended on such a great note. Oh man, with the new Horizons Flyby of Ultima Thule. Oh, that was amazing.
That really was. Oh my gosh. The entire year was so crazy. I mean, so much stuff happened this year that it was a little bit hard to keep up with it all and keep track of everything. I mean, just rocket launches alone. I mean, this year we had 114 rocket launch attempts, and 111 of them were successful. I consider it 112 because one of them was a partial failure. There was an Ariane launch, an Ariane 5 launch from Kourou for the European Space Agency that successfully placed a payload into orbit, but not into the correct orbit that it was supposed to be in. So everyone's considering that a partial failure. But I'm like, well, the rocket worked. I mean, the satellite still got into orbit. Yes, it had to use some of its own propellant to get into the correct orbit it was supposed to be in, but I mean, it still works. So I'm counting it as 112, but that's just me arguing over semantics. But the craziest thing is that's more rocket launches since 1998. And in 98 too, there was 83 rocket launches. We're getting close to the previous record, which was in the 80s, like 84, where we had 114 rocket launches. And next year in 2019, there's 177 rocket launches that are planned. Probably not all of them are going to take off, but even if most of those take off, there's a chance that this year of 2019, we might see more rocket launches in 1 year than we have seen in the previous 50 years of space flight.
Wow, space is back, baby!
Yeah.
Just bring back heavy metal and my life will be complete.
Bring back heavy metal. I mean, I think the heavy metal is still pretty prominent, you know. I mean, there's still a lot of concerts going on. But, you know, we might as well try to make it to as many launches as possible. And we can just bring a radio and play some heavy metal for you, Mac. That would be pretty fun. I think the heavy metal and rocket launches kind of go hand in hand. It's, you know, really epic stuff happening. You got the rumbling of the rocket. I always say, too, it's like, it's great to see a rocket launch, but feeling it is a whole new thing. Last year, I actually attended 3 rocket launches, which was the most I actually ever did, which is kind of a bummer because that's only 3 out of how many you said for last year? 114? So this year, I mean, with 177 coming up, I have a goal of seeing at least 20 rocket launches, especially living, you know, on the coast where, you know, right by Vandenberg, where most of SpaceX launches leave from, at United Launch Alliance, NASA. They launch a lot from there as well. So have you guys ever actually traveled overseas for rocket launches?
We were scheduled to go to one. SpaceMike and I were supposed to go to Russia this year. We were actually supposed to see the launch that was a failure/success that we really want to talk about. Yeah. That was the launch we were supposed to go to.
Wow.
Yeah, we almost went to that one, the Soyuz MS-10.
MS-10.
But it also coincided with a different trip, though, so it just was getting a little bit too much. But we actually were in Jordan right around the same time, and we're flying back like right as that was happening. Like it was like the day after our flight that the Soyuz MS-10 flight happened.
It was either that or the pyramids, and we ended up doing the pyramids.
Yeah, I think so.
Well, the pyramids, that's a good thing. I think that's something you definitely got to visit.
Oh, and for those of you watching online, I'm going to show, for those of you watching the video online, I'll show pictures of SpaceMike and myself wearing space suits at the pyramid. At the Pyramid of
I gotta
Giza,
see
where
that.
We
I
had a lot
haven't
of
even see
fun.
that.
Yeah, that was a lot of fun. That was a
But
lot.
Space Mike and I
amazing.
did end up going to the Antares launch in out of Wallops Island in Virginia.
That's right. Yeah, we saw
Ooh.
the OA-10 launch. It was the last launch under orbital ATK before they switched over to Northrop Grumman Innovation Systems now. Um, so like the classification numbers, like now it's the NG-10 is the next Antares mission. Excuse me, we actually saw the OA-9. That was the last orbital ATK mission, and me and Mac went there and saw it live. That was back in May of last year. And that was incredible. And just like you were talking about, Athena, it's a whole different experience when you feel it, because you do feel it. I mean, we were a ways away. We were at the public viewing site, but even we could feel that rumble in our chest when it was getting off the pad. And Antares is one of the smaller ones, too. It's a medium-sized rocket. So for the bigger ones, I mean, the only other rocket launch that I had a chance to see was the last space shuttle launch. And, I mean, that thing was massive, so you could really feel that one. Oof.
Oh, I never
Wow,
got
yeah.
to see
Next
a
one,
space
though.
shuttle launch. I am too young for Apollo, and the space shuttle started when I was only 6 years old. So I grew up with the shuttle, and it's been my. I was that kid who wanted to be the shuttle astronaut. I was going to be on Discovery, and
Wow.
it came and went, and just never had an opportunity to see one. Growing up in Michigan, you don't really have an opportunity to see one unless you go to Florida for Disney World, and people don't realize that the shuttle used to get delayed and delayed for weeks and months at a time. So when we're having a SpaceX delay or a ULA Delta IV Heavy delay that we're having, it was supposed to launch today. Actually, we're recording this on January 6th, and it's been delayed again. And when it's only delayed a few days, and people are complaining, they don't realize. With these human space flights and the shuttle and the delays that happened there were incredible.
Yeah, I mean,
And
and
this
that's
next
the
one,
thing. It's rocket science. It's it's not a walk in the park. And I mean, maybe one day it'll actually reach that point, which is what Elon Musk is obviously looking to do with having the reusable rockets with Block 5 configuration, being able to just kind of fix a few things, shine it up a bit, and then send it back into space. It's it wants to be as common as getting on an airplane and just filling up the food and the fuel and then setting it off. That's what I'm actually really looking forward to with Virgin Galactic for 2019 and for future missions that they're actually looking to do. I mean, they had an amazing test actually last year in 2018. And with what they want to do with space tourism, I think that that's something that we all have to really look forward to with the future of space flight, because that is kind of like what I'm looking forward to as being more of the entertainment side of space travel. Of course, the scientific and research side is important, looking to colonize Mars and understand more about like asteroid mining. But, most people are looking into the more entertainment side, like, okay, who's going to be the first performer in space? What's going to be the first meal I'll eat in space? I think that that's something that's really going to come out of Virgin Galactic's missions.
Yeah.
Hey, I'm a space
And
nut,
Blue
and I want to
Origin
know
as
that
well.
too. Exactly. I like to get inspired too.
And I think that's what's going to inspire a lot of people that maybe don't know yet that they're space fans, that because a lot of people have the same story that you do, Mac. I mean, I have the same story as a kid, really being into what's going on with NASA and everything like that, and then just kind of falling out of it. If you're not living nearby where that stuff is happening, it's so easy to fall out of your love for space flight. And those of us that are lucky, there was an event that for a lot of us that kind of brought us back in, something that we heard. For me, it was stuff going on in 2008 and hearing about SpaceX for the first time, being like, whoa, there's a private company that's doing something, and just researching and being like, what is going on with the space shuttle nowadays and the space station, and who is this new company, and being blown away by everything. So I feel like that adventure that Virgin Galactic and Blue Origin are going to offer this year. I mean, Virgin Galactic had their successful flight last month, and they're going to have a couple of more test flights before they start flying customers astronomers into space. And Blue Origin, they're going to start launching this year as well. I mean, they've already been launching their rocket that's going to go into suborbital space, but they're going to be launching people on it this year for the first time. And that flight might be any day now. I mean,
they're doing another
had a history
test
of being
any
really
day now.
secretive.
They had a scrub in December, and they should be having another launch. Just a few weeks ago, Virgin Galactic, just like you said, they actually made it to space, or is what the U.S. Air Force defines as space. Even if they don't, it's just such an incredible milestone for humanity. And that's one of the things that brought me back, or inspired me to even start Borderless Labs and even this podcast, is rediscovering my love for space and marrying my two passions, which are philanthropy and space and science and STEAM education. And that was really through discovering you guys at Tomorrow, and you guys are the ones who inspired me to do all this. You guys are doing a great job, and I figured there's absolutely no supply for hundreds of millions of people overseas who don't have this content in their own languages. And I'm fortunate that I'm at a point in my life where I can say, well, let's do something about it. So thank you guys for being a part of it. And let's hope we can make this happen for everybody.
Yes, definitely. I mean, thank you, Mac, and everything you said about Tomorrow, too. I mean, Tomorrow has just become such an awesome community on Saturdays. For those of you guys that don't know, it's a live show every Saturday, a live stream show on YouTube, and we've brought so many just very inspiring people that will interview and talk about their life journey in astrophysics or in space travel or engineering or even like space policy. And it is just amazing learning the stories from these people that are very busy kind of doing their thing, like doing research that their story a lot of times doesn't get told. And I think that's something very special that I really fell in love with actually at Tomorrow, and now with what we're doing with Borderless Labs. And I think that this is just such a valid and important thing, because SpaceMike, you said something so valuable. You were saying, a lot of times if we live in areas where you're a little bit more separated from space, or maybe you're not on the coast during like the space shuttle program, or for instance, like for me living in New York City, growing up here, there was a lot of light pollution. I didn't get to see the night sky. First time I saw more than like 5 stars was actually the first time I went to the Philippines, and I saw like hundreds of stars, and I was like, what is this? And I remember it just blew my mind, and now I've become so deep into my research in astrophysics, and I think that that's something that's so special, because we start to realize how much bigger our place is in just existence alone than what we kind of think it is when it comes to society and civilization that we built as human beings. So, I mean, I love that. And there were so many amazing discoveries that were made in it last year in astrophysics. I know you guys were talking a lot about the launches that were amazing, which were great, but there were so many discoveries made as well in space.
So crazy.
Oh my goodness, I know. But before we talk about those, I got a question for you. Now, what's the difference between astronomy and astrophysics? When I was growing up, everything was about astronomy. You're an astronomer. Carl Sagan is an astronomer. Everyone is an astronomer. Now I'm hearing the term astrophysics. Is there a difference, or is it just, what am I not understanding?
I mean, well, technically speaking, as far as the definitions go, so astronomy really was always just the science of really measuring the positions and the characteristics of the heavenly bodies, whereas astrophysics was more about the application of physics to understand astronomy. But honestly, in modern day, these two words are really interchanged quite a lot, because they kind of mean the same thing. Astronomers use physics to understand like heavenly bodies and stellar objects. That's kind of what I mean by heavenly bodies, because it ties way back into Galilean time. That was their terminology. So it really kind of is just the same thing. But definition-wise, astrophysics was always considered to be using physics to understand astronomy. But that's really what all astronomers do today, especially astrophysicists. However, when it comes to universities, I notice there still tends to be separations in departments. for instance, like where I went to school, actually, there was a minor in astrophysics, but then there was some other universities that tend to have astronomy as a major or astronomy as a minor, and then you can kind of have a secondary major in physics. So there is still kind of, I think, a bit of that separation. I like saying astrophysics because it sounds really cool, and technically speaking, you have to use physics nowadays to understand astronomy.
Once upon a time, I came from the sports medicine industry, and we had multiple different terms that people would not accept. For example, if you are a registered dietitian or if you're a nutritionist, don't you dare call a registered dietitian a nutritionist. When you went to school and you have a bachelor's and a master's degree and you're registered and you're certified and you're a registered dietitian, you feel like you're not being acknowledged, and your entire industry is being taken over by non-professionals. So is there and this same goes to my previous field. Are you a exercise physiologist, or are you a kinesiologist? And a lot of people, say at the end of the day, you're all personal trainers. But
so
you
funny.
can just do a online course and become a personal trainer, or you have to have a bachelor's degree with a master's degree and pass all these board exams to be a clinical exercise physiologist at the end of the day. So
it just goes to show that no matter what industry or what field we're talking about, there's so many specifics and so many different things. I mean, the way that I look at it, I mean, astronomers are looking at stars, yes. So are physicists, but they're trying to measure the physics of it, understanding the gravity and the influence of these different stellar objects. It's just like engineering. You might have an engineer and then you have an electrical engineer. They're both engineers, but one is more focused on how to do things with electricity rather than mechanically or whatever. So, there's just lots of different ways where you can split hairs and argue about semantics with it, when at the end of the day, yes, you're kind of both doing the same thing, but there are so many aspects to truly understand the world. And I feel like the discoveries that were made this year, astronomically, I mean, have helped us to understand a little bit more about our place in the universe. So, Athena, I mean, what are some of the crazy discoveries that you were most excited about this year?
Yes. Okay. So there's this thing called a proplid, which is one of my favorite things, I think, in our entire universe. It just hits home for me because that's what I actually did research on back in undergrad. And it's called the Protoplanetary Disk. So that crazy word, it pretty much just means like the early formations of a planetary system. So you have a newborn star, and when it's born, it's spinning really, really fast, and a lot of nearby dust and gas starts to accrete around it to form a disk. And in this disk, lots of rocky objects similar to Ultima Thule will start to coalesce. They can start to collide and combine, and eventually planetesimals can start to form, which are like that stage just before it's a planet. And then eventually it forms into a planet, and then possibly, if it's close enough to its star, if it's in the habitable zone, also called the Goldilocks zone, which means it's not too far, not too close, it's right in the middle where it actually can potentially harbor life. An atmosphere can possibly form, and biology can possibly form. And this is just so important to me because it's about trying to find life beyond Earth. And we're gifted with being in a place where we can literally point our telescopes in one direction and see the death of a star, point our telescopes in another direction, see the birth of a star. We can see birth, existence, and death all at once and recycling all over again. And that's exactly what protoplanetary disks are to me, because they form in nebulae, which is actually remnants of a massive star that exploded and died. So it's a big cloud of dust and gas. So what was discovered last year was 20, very, very recently actually too, it was the very end of the year, it was in November, there was 20 very sharp high resolution images taken of 20 new proplids. And it was taken actually by ALMA, which is the Atacama Large Millimeter and Submillimeter Array. That's out in Chile, by the way, so anyone in Chile, kudos, awesome. And what they found was they were able to image like rings starting to form and gaps. And that sounds kind of crazy, like why is that important? because that's literally right where planets will start to form, because this disk around the star is already starting to separate, and it's starting to collide in regions. So it's starting to now accumulate into potential planets. And it's like, okay, well, this is normal, but it's usually normal over 5 million years. It takes about 5 million years just from what we've observed, throughout all of history of astrophysics and astronomy. But what's weird about these is they started forming at only 1 million years old. So that's breakthrough, because that's just like, wait a second, if they're able to form at just 1 million years, what does this tell us about how maybe we formed, where we thought we, would have taken billions and billions of years, which, well, is true because our sun is 4.6 billion years old. But this is really important to recognize, because maybe there's other planetary systems out there that will form in only 1 million years. So that was something really, really exciting. What's shocking is a couple days after that, another study came out, a discovery about one of these proplyds. Instead of a planet forming in these little disks, another star formed. So that became a binary star system. So it just, and this was right at the end of the year, so my mind was just exploding with excitement. So yeah, that's what ended up getting me the most excited about this past year.
This reminds me of a Star Trek Voyager episode called Blink of an Eye. It was a story about how a planet is forming around a planet. Oh my God, Star Trek fans are just going to rip me apart right now. If I remember correctly, it was a planet forming around a pulsar, so it was spinning very quickly, and when you're moving that fast, obviously time moves differently, and time moves so much faster for them. So evolution and societies and everything all happen in a blink of an eye, compared to our perception of time. And the way you're just describing it made me reflect on that. And for someone who was inspired to love space because of their love for science fiction, I think that's where our passions can inspire each other.
That's amazing.
That's something crazy to me, too, because a lot of the stuff that I have learned this year about human spaceflight and a lot of the tests that we've done, looking at far-reaching plans about people that are going to be born on Mars and different places, I mean, something like that would be totally possible, because it all depends on where you are. If you're on a planet that is orbiting around a star, your circadian rhythm is dependent upon the gravity of the planet that you're on and where your orbit is orbiting that star. The people that are born and live and die on Mars in the future, their circadian rhythm is going to be slightly different after a few generations than people who live and die on Earth, which means that they're going to age ever so slightly slower. They're going to live little bit longer, but from their perspective, from their reference of time, it'll be the same thing. They're still living out an age of, 70 to 80 years, but in Earth years, that might be extended out to 100, 110, 120, and they will age slower to kind of keep that fit. And so if you're on a planet that is really, really, really far out in a solar system that would be large enough to, sustain life and somehow was able to be have a habitable system if it was outside of the Goldilocks zone of a star, just hypothetically speaking.
Well, you guys are saying Goldilocks. Can you guys remind me of that term?
What is the Goldilocks zone? Yeah.
So
the Goldilocks zone, from my understanding, is a zone around a star where the temperature is just right. It's not too hot and it's not too cold, so that liquid water can form and an atmosphere can develop, and it won't be bombarded by the radiation of its host star, and either have a situation like Mercury, where its atmosphere is completely stripped, or too hot and have a runaway greenhouse effect like Venus, or just be right outside the Goldilocks zone and it's too cold like Mars, and it's just too cold for liquid water to exist on the surface.
Not too hot,
not too cold. How
did I miss that?
Yeah, those astronomers are clever with their names and their terminology. I love it.
Gotcha. But the idea is not too far, not too close, not too hot, not too cold, because of liquid water, or because of if you're too from my understanding, what the Kepler Space Telescope is finding, and all the planets that we're finding are rotating around their star so fast in a way that we can actually detect it, and we're talking 15 days and 7 days, so if they're that close to their star, wouldn't they most likely be tidally locked?
Well, it also depends too on the mass of the star. So like for instance, the TRAPPIST-1 system, which is really exciting to talk about. It was actually discovered a few years back, and it was announced to us, I believe, about 2 years back. It is so that's 7 Earth-like planets that are orbiting in that Goldilocks zone we spoke about, that are really close to its host star, which is actually a brown dwarf star. So what that means is it's actually a lot cooler, meaning it's not giving off as much radiation, meaning it's safer for the planets to actually be orbiting closer. So that's actually a pretty good thing, because if they're too far out, like where Earth might be in retrospect to our sun, which is a lot bigger, a lot hotter, then they probably would end up getting too cold, because their star is actually a lot cooler. So it really, the Goldilocks zone varies also depending on like the type of star that it is. So that's definitely something to keep in mind when it comes to exoplanetary systems.
The size too. I mean, a brown dwarf is much, much smaller than our star, whereas like like a red giant is huge. I mean, there's certain stars that are the size of them go beyond the orbit of Earth and Mars and our asteroid belts. I mean, some stars are huge, whereas you have a tiny, tiny little star that, yes, there might be a planet that's orbiting around that star in only 7 days, but that's our perspective. That's our reference of time. That year, that 7 days that that planet orbits around that star might be just right. And let's just say that there is life, on one of those planets that are orbiting, where it would be like that situation where that Star Trek episode, where whole civilizations would live and die in our perspective of a year. But our perspective of a year would be hundreds of years on a planet that orbits around its star in only 7 days from our perspective of time. Mind blown, right?
So cool. And those big, big stars are the exciting ones, because they're the ones that explode.
Yeah.
If it is tidally locked, one thing you can say for sure, that if that planet is tidally locked, then the other side of that planet is the dark side of the planet, not just the far side of the planet.
Yes. But then you'll have lots of major storms happening, really crazy weather conditions. One side will, I like to say, be potentially deep fried, and the other side will be like, be like frostbite. It would be really intense, and you can start to have really crazy experiences with your atmosphere. One side might not have the atmosphere, but the other side will. But because it's so hot, you might get lucky, and maybe some of the hot atmosphere and the hot air can actually move over to the warm side. But that's that's very like kind of out there. We haven't actually observed that just yet, but it is possible. So, but
the reason why. Yeah, the reason why I brought up the dark side of the planet, since it's a star, is because I wanted to segue into one of my favorite missions this past year that really carried on to this year. Just a few days ago, China managed to land a lander and rover on the far side, not just the dark side, but the far side of the moon. And
Chang'e 4.
That just blew me away, and you guys had talked about it on Tomorrow. Anyone listening, you got to go to youtube.com/TMRO. I've always been a fan of everything lunar. I know this term's not mine. I'm not original, by the way, so everything I say is borrowed or stolen by someone else. I don't know where the origin comes from, but I love the moon so much. I'm a lunatic. And thank you. I was waiting for that.
That was good. I purposely paused because I just had to. I was like, wait, let me let that moment settle for the audience.
What, you've never heard that one before?
I have. I think like maybe, I think I have. I'm not sure. This might have been the first time actually I heard that. Kudos to you, Mac.
No, actually, I heard it at the Humans to Mars conference a couple of years ago in Washington, D.C., and one of the guests was saying the water on the moon, whatever water we find on the moon, we shouldn't use it for rocket fuel to go to Mars. We should leave the water on the moon for the loonies.
Okay.
So I'm like,
Got it.
very clever, and I've never heard that before. And
The lunar
yeah, I figured.
colonists.
And if I remember correctly, one of your guests on tomorrow has a license plate that says Luna-Tick or something. Lunatic. And,
I gotta find out who that is.
and I'm like, I'm one of those. I'm one of those too. Yeah, I love them and so much, and I can't believe that we haven't gone to the moon for ever and ever. The last mission that I remember was the Chang'e 3, and before that, the L-Cross mission?
Yeah. And I wouldn't even consider that a proper lander. I mean, that was an impactor, really.
Yeah.
But
No, but just going to the moon, and yes, and we've had orbiters in the Lunar Reconnaissance Orbiter, and but I mean, China's officially sending rovers to the moon, Chang'e 3. And tell us more about, you had a great video for our listeners. Go to youtube.com/SpaceMike and watch his video about that lander.
oh man, I mean, Chang'e 4 is really crazy, and we haven't seen nothing yet. This year is going to be so insane. I mean, Chang'e 4 was a backup to Chang'e 3, which you talked about. That landed on the moon in 2013, but it landed on the near side of the moon, the side that we can see. In fact, it wasn't too far away from one of the Apollo landing sites. I can't remember which one it was right now. I think it was the Apollo 12 landing site, I think, but I'm not sure. But in any case, it was on the near side, the side that we see, because our moon is tidally locked, and we only see one side of it from the ground anyway. So this one, Chang'e 4, is the first time that anyone has landed a lander or a rover on the far side of the moon. United States hasn't done it, Russia hasn't done it, China is the first one to do it. And the instruments on board, even though this was a backup to Chang'e 3, the instruments are completely different, and they were all supplied by a lot of universities and companies within Europe in collaboration with the Chinese, so all of their data is going to be published worldwide, which is great because we didn't get a whole lot of data from Chang'e 3. We got a little bit, but they didn't really share a whole lot other than just a few initial results of, yes, our spectrometer worked. But we didn't really get any data beyond that. So Chang'e 4, all that data is going to be shared. And one of the experiments that I'm most excited about, well, first off, before I get to this one, they're going to have spectrometers looking at the mineral composition on that side. And I'm not sure if it's just the cameras aren't calibrated, but it looks like from the images that they've returned so far, it could just be the lighting, but the ground looks very brown. And
that's what I noticed.
It doesn't look like your classic moon. Yeah, it's a little bit reddish, so it could be different type of material. Maybe similar type of material that, what's his name, Harrison Schmitt found on Apollo 17, that really weird orangish material that he found.
Orange dirt that they found. Yeah.
Maybe it's something like that. I don't know. Again, it could just be the camera hasn't been calibrated correctly, because the rover is supposed to be kind of white on the underside of it, and it also kind of looks a weird orangish yellow. So might just be the camera, but maybe not. We'll find out, though, because as I said, the data is going to be shared with everyone. They're also looking at radar. They have radar on board to look at the layers of the soil and also see if there's any lava tubes, some subsurface lava tubes that are hollow on the inside, anywhere nearby the landing site, which is the Von Karman crater, part of the South Pole Aitken Basin. And Chang'e 4, oh my gosh, it has a canister on board that is a small biosphere that has potato seeds, seeds for a weed called Arabidopsis, or otherwise known as thale cress, and it also has some larvae.
Biosphere?
Wow.
Yes, a little biosphere, and there's even silkworms inside of it. And they're going to be live streaming the thing. I mean, it's going to be like on tomorrow, we had a live stream that was going for a couple of weeks showing plants grow. So, I mean, it's going to be like that. It's going to be very boring. I mean, it's going to be exciting when they finally see a little seed pop out. But the exciting one for me is going to be when those larvae hatch, when those cocoons hatch and those little silkworms crawl out. And I mean, they're doomed to die up there. I mean, the oxygen, the little amount of pressure that's in this canister is going to run out. But the whole idea, the whole test of this is to see how the plants are going to develop in 1/6 gravity. We've grown a lot of stuff at the International Space Station in microgravity or zero gravity, and they grow in all sorts of weird type of ways that's really interesting, but we don't know how plants are going to grow in minimal gravity. Here on Earth, you know, we understand how plants are going to go, and their kind of DNA is set up to grow in the gravity environment of Earth. So
you're telling me European students or European universities sent an actual biosphere with living organisms and plants that's sitting on the moon right now?
I mean, it's tiny. I mean, it's like twice the size of a coffee cup, but there are living organisms on the moon right now that we sent them.
Wow. Have we ever done that before? Did we do that with the Apollo missions?
I don't think so. I don't know. That's something that I'm going to have to do some more research on, but I don't think that the Russians had anything like that either.
I think the first farmer in space to measure, I think that was, God, was that shuttle or was that Skylab when they took plants into space the first time? So I remember I was a kid and it was national news, international news, that to watch these plants grow in space. So I was alive at the time when they were showing the science of plants growing in space for the first time. It might have been Skylab. But
I'm pretty sure there was. Yeah, I'm pretty sure there was an experiment on Skylab, but the kind of more complex ones first started off on Mir. And I'm old enough to remember one of those experiments on when Mir was still around and American astronauts were going to the Mir space station.
Oh, I remember when Mir crashed into the ocean, or the days and weeks leading towards Mir crashing into the ocean, but they knew it was going to be a controlled crash, and they knew exactly where it's going to go into the Pacific, and everyone was reflecting back on the international chaos and international panic of the Skylab days. And 79, when Skylab was falling and it was falling out of control, nobody knew where it was going to fall. Everyone thought it was going to be their house. That was it. And this is worldwide. So I went to Jordan in 84, and people were remembering that some people really panicked and actually had panic attacks, knowing it's going to be tomorrow, it's going to be the next day, and it's going to be me, it's going to be my house, we're all going to die. It was going to be so. And when you talk to people of that era, and you just remind them, and it slowly comes back to them, and they'll remember, oh yeah, that was international panic, that was Cuba Missile Crisis level. You know, everyone talking, thinking about the same thing, heartbeats, you know, blood pressure.
Castles falling from the sky, man.
On a worldwide level, yeah.
Wow. And nowadays we'll just be like, no, it's all good. I got it on GPS. Look, I can track it on my phone. Like, it's just, wow. How
no, and the Chinese, and one of the things that happened last year that no one has mentioned is China actually had a space station in orbit that actually deorbited and crashed into the ocean. But we didn't have the panic that we had during Skylab or Mir.
Even though it was this really similar situation. Tiangong-1 is the one that is the space station that you're talking about, and it was an uncontrolled reentry. They had no idea where that thing was going to reenter. They had ideas, of course, they had projections and whatnot, but they really didn't know where it was going to reenter.
It was the exact same situation,
panicked. Yeah, no one really panicked.
But did they kind of know it was going to hit the water, though, right? They knew it was going to go in the oceans, not like hit land.
Right,
well, they kind of assumed that really since the Earth is, 66%, you have a 66% chance that it's going to hit water.
Right, but there was no, I don't remember anyone having like a fear of it actually hitting the land or hitting their home. So, with our technology today, we have to be able to at least kind of track that, right? For like knowing where approximately it's going to land. Okay, so that's a little bit different. Like, so to say, I'm like, I don't remember panicking a few months ago about that.
And like the hours and days
Skylab.
leading up to its actual re-entry were fine. I mean, they knew exactly where it was going to re-enter. But before that, the months leading up, when we knew that it was out of control, that's when it was kind of that, not really a fear, but just like we don't know where it's going to re-enter up until that final thing. And yes, we have a much better system now with tracking satellites that track all of the objects that are in space, even space junk, up to a certain size anyway.
Space junk.
So to the hours leading up to it re-entering, we knew exactly where it was going to go. And I say we collectively as a species. I don't mean like the United States or China or anything like that. But to go back to the moon for a minute, just to kind of wrap up with China, is they're going to be launching another moon mission this year called Chang'e 5, which is a really similar lander, but instead it's not going to have a rover on it. It's going to have a sample return capsule. So there's going to be a small rocket. Think of it as like the lunar lander. Yeah, there's going to be like a lunar lander like the Apollo one, where the upper part of it, the astronauts, the ascent stage will take off from the lander after it has gotten some samples, and it's going to take off and return those samples back to Earth. So I'm really excited. I hope they're going to land it this year, but whether or not the sample return takes off this year, I'm not sure, because it's going to be a little bit later this year. But if that happens, one of the running jokes that we have on tomorrow when we cover all of the orbital rocket launches of the year is our total is this is how many launches were from Earth. So this year we might get to see the first launch from the moon since what, 1970, 78? 79?
73, I think.
73, you're right. Wait.
Yeah.
Well, no, because the Selenocods did sample returns as well. I think one of those was in 76. The Selenocods were the Russian moon rovers that returned samples. And I think the last one was in 76, but I'm not sure. I'm going to Google it right
the Apollos ended in 72. And the Soviet Union had a sample return mission in 76.
Mm-hmm.
And we haven't been there, or we haven't done it since. There has not been a launch from the moon since.
The last Apollo mission with humans, and the last sample return that the Russians did in the 70s.
And this is all happening this year.
This is all happening this year. And not just that, I mean, this month is going to be crazy. Well, actually, it just got pushed back. But in the coming weeks, India is going to be launching their own mission that is pretty much just like Chang'e 4. It's a lander and a rover, but it's going to be landing on the near side. It's not going to be on the far side. And it also has an orbiter as well with that mission. So India is going to have their own mission, Chandrayaan 2. And then also next month, the Israeli team, Space IL, that was competing in the Google Lunar X Prize, is going to be launching their lunar lander. It doesn't have a rover or anything else on it. It's just a lander, but that's launching on a SpaceX Falcon 9 rocket next month. So this year is going to be the year of the moon.
Wouldn't that be the very first commercial private company that actually makes it to the moon?
Yep. Unless Blue Origin does some sort of secret launch before then.
Wow.
I know, Athena, you were excited about the Israel launch.
Yes, for Chandrayaan 2. Yeah, I was actually super excited, because it was originally going to be launching at the end of this month, January 31st. But I believe now it got pushed to mid-February. But yeah, I'm just excited because I realize like there's not a lot of recognition to ISRO, the Indian Space Research Organization. So I think that's one thing I'm actually making a goal of mine, may I say a New Year's resolution, is to actually do a lot more research into what's happening globally with space exploration, because it's pretty easy to get caught up in, like the big names of SpaceX and NASA, Blue Origin, which, because they're doing great stuff and they're right here, like my neighbor. But one of my goals is to really start to shine some light on what other space agencies around the world are doing. So that's why I got really excited about Chandrayaan 2, because it's their second lunar mission, but the first time that India will be landing on the moon. So I think that's a big thing to recognize and applaud.
Yeah.
Definitely so. And speaking of the Google Lunar X Prize teams, isn't Moon Express and Astrobotics, aren't they supposed to launch on a electron rocket to get to the moon? Is that still on the books?
Potentially, yes. They actually just got a contract with NASA. They are two of 11 companies that are contracted now to send small payloads to the surface of the moon. Both of those companies, Astrobotic and Moon Express, have designed a rover that would be small enough that would be able to launch on an Electron rocket from Rocket Lab, which is a very small class rocket. And the upper stage that would come with it would be enough to put it into a lunar trajectory, and then they would use its own onboard engines to put itself into orbit or to just attempt a direct landing from whatever trajectory that they're at.
So you're telling me that I had to wait 4 decades to see some action going on at the moon, and now people who are joining the space industry and becoming fans today get to see 6 missions in 1 year just like that, when I had to wait 4 fucking decades?
Right? This year is going to be amazing. This year's the year of the moon.
This is incredible. This is incredible.
Man.
And not just that, human space flight. So human space flight is back.
Yes. Yes. So much human spaceflight is happening this year. I mean, right now, SpaceX's Crew Dragon is sitting on the launch pad doing its checks to do its first uncrewed mission to the International Space Station. And that's exciting because if this vehicle works, the very next mission with this Crew Dragon is going to have people on it. Boeing is developing their CST-100 Starliner that's also going to have people on board. And then India, they're developing their Gaganyaan spacecraft, which is going to have 3 people on board. And they won't be ready to launch that this year, but they are making the goal of launching it for the first time next year in 2020. So they're going to be doing we're going to have all sorts of news talking about ISRO and their human spaceflight program this year. I am so excited.
Yeah, one of the things that I lost, but I was following that, but I haven't heard much about is their shuttle. Whatever happened to India's little baby shuttle?
They have flown it. They did a little baby shuttle that, what they did is they did a test flight with one of the solid rocket boosters.
Landed in the water or something, right?
Yeah,
but
yeah. It's a booster that's on their PSLV rocket, yeah. And their whole idea with this is to have something that would kind of be like the United States X-37B, which is a small little robotic space plane that can be up in orbit for, years at a time. And their whole program is a bit secretive as to what payloads they've taken into orbit. But the idea is that if you have a space plane like that, not only can you have, I'm assuming, very delicate scientific payloads that you want to be able to land back at a runway nice and smooth, but you can scale it up and have it be a human shuttle. And I think that with ISRO, I think that they were there was 2 competing plans. There was one of having their own space shuttle and then one of having their own capsule, kind of like the Apollo capsule or what we're developing now with the Orion and the Dragon and the Starliner, of being a capsule to send humans into space. And it looks like with the decisions that were made just this last year on how ISRO and India is going to move forward with their human spaceflight program, it looks to me like the capsule won out, because that's what they're pushing all of their funding into and what they're going to move forward with their program. However, they still might use that little mini shuttle, but just for scientific payloads and not ever really scale it up to be a human space shuttle, unless they decide to do that in the future. I'm not saying that that's off the table, because I don't know what their internal plans are, but just from the information they've released, that's what it looks like the situation is, that they're still going to use it as a unmanned robotic space plane, but all of the rest of their major funding is going to go towards the capsule for their human spaceflight program.
Wow.
Incredible.
Wow.
So moving forward with this podcast, we have so much to talk about. Oh my God. So basically what you guys just heard is just a sample of what we have coming forward to you in 2019. It's going to be an incredible year. If you've been following space astronomy, astrophysics, rocket launches in 2018, you saw how amazing and epic it was. Falcon Heavy launch, we didn't even talk about that yet, but we have weeks to come, episodes to come, and it's just going to be amazing, epic conversations about that. gets me so excited. I am so looking forward to having conversation after conversation about every aspect of space flight. But the last thing I want to touch on before we wrap up the hour is Athena, you were talking about the milestones that happened, and one of them just happened this New Year's, and that is the new Horizons flyby. And you were really into that one.
Yeah, I mean, I was super excited about the New Horizons flyby of Ultima Thule, also known as MU69. And I mean, some people have been calling it a space snowman or a Team Peanut. It's really cool because this object found in something known as the Kuiper Belt, which is a band just beyond the orbit of Pluto. So it's about 6.5 billion kilometers from Earth. There is a bunch of these like rocky objects that are formed. Usually they eventually become like asteroids, comets, if they are pushed out of orbit. But they were around from the dawn of our solar system. So they date way, way back. They're billions of years old. And Ultima Thule is one of them. And so New Horizons just flew by it. It was, oh my gosh, I think a minute and a half after New Year's on Eastern Standard Time. It was just so cool. I mean, I had like 5 different live streams on my computer at the same time. And it was just such a monumental moment. Like, everybody was getting excited. I was here with like my family, and we were watching that and also watching the ball drop in New York. So it was, I think, such I feel like NASA has this really good way of making things happen around certain times of the year, just like the Earthrise, which was on Christmas Eve many, many decades back. And this was just, it was such an exciting flyby because, I talk to people that are non-space interested people. And I don't say non-space people because maybe they're not interested in space. You can be interested in space, like you were saying before, but not be a astrophysicist, not be a rocket scientist. You can still be interested in it, be a fan of it. I was talking to people that aren't technically fans. They would never want to go to space.
I'm not in the industry. I'm just a fan.
And
I
you're just
love
a fan.
It so much.
Yeah.
I'm not an athlete, but I'm a fan of football too.
Yes, exactly. And so what I've been talking to people about Ultima Thule that don't even consider themselves fans of space. I mean, they are like, I don't want to ever go to space. I am cool with just seeing one star a night. Like people like that, and like my friends, and I would talk to them about this, and even this blew their mind because I was like, the thing is, we're looking at like the very early stages of before Earth even formed. We're looking at our companions in space, and the more research we do on that, the more we understand about that, the more we can understand really about ourselves and about how we got here and where we came from. And I think that's one of the biggest questions that anybody on this planet Earth can't deny wanting to know the answer to, is who are we and how do we get here? And I think, just this mission alone was I think a big step for not only scientific research, but for all of humanity. So that's why I honestly was really excited about it, was from that aspect. Then you go into all the science stuff, and that's really cool, like the rotation of how it was actually facing head on to New Horizons, which is why we couldn't see something known as a light curve, meaning just the object getting brighter and darker. But yeah, it was just, man, it was so good. And there's so many other things happening in 2019. There's going to be 9 meteor showers. So lots of things. You guys just, turn off the lights and look up at the night sky. That's kind of where I would conclude on here.
Yeah, speaking of meteor showers, I mean, there is, like you said, there is a lot to see in the sky. And if someone is just getting excited and they just want to, get involved. They're like, okay, I love it. I want to get involved. I love astronomy. I don't know where to start. I don't know how to start. Where do they go? What can they do? How can they for me, it was just opening YouTube video after YouTube video after Carl Sagan, Neil deGrasse Tyson, planetary radio, just absorbing as much information as I can. But if they physically want to get involved, they want to see the stars, what can they do?
Well, let me tell you, there's something that was started by the International IAU, which is International Astronomical Union. It's called 100 Hours of Astronomy. You guys can totally go to the website. It's literally www.100hoursofastronomy.org. And it's starting actually very soon. It's starting on the 10th of January, going till about the 13th. And it's one of the biggest events to take place throughout the entire planet. There's registered events where you're going to spend over 100 hours of just like, you know, looking up at the night sky, looking at the wonders of our universe. If you go on there, there's actually a tab that says registered events, and it is all over the world. I mean, there's Brazil, there's New Zealand, there's Nicaragua, there's Thailand, all these events. So wherever you guys are, you can totally go to an event near you and meet also other people.
Wow.
Community is so important too, especially when it comes to this stuff. You learn from other people.
Yeah, I just went to their website, click on events, registered events. You see a map of the globe, and in purple you see every country that's having events. You click on your country and underneath it, and there's a list of events. You know what? Here I am going to click on Washington, D.C. area. Oh my goodness.
There's so much stuff that's going on all over the world. And I mean, no matter what you're into, there's probably something nearby that you can get into. I mean, for me, there's lots of rocket clubs and stuff like that. But spaceflight brings people together. Spaceflight brings out the best in people. And no matter who you are or where you're from, you can get involved with this sort of stuff and collaborate with people all over the world and just sharing your excitement for all this crazy stuff that's going on. And yeah, no matter who you are, you can get involved with spaceflight.
Happy Hour Star Party at the Milk House Brewery in Mount Airy, Maryland. I think I know where I'm going on the 11th.
Amazing.
There you go.
Get to see the stars and a brewery, check out some local crafts. Beautiful.
Wow.
There you go.
Well, thank you so much.
And finally get to speak to like-minded people in person.
Yes, so important. So important. Because you learn from each other and you inspire one another too. It's like if someone says something you don't know, you're like, wow, I need to go research that or ask them what it is. And you learn so much, honestly, just from other people. I've learned so much just from my colleagues. I mean, from SpaceMike and from Mac, even just this conversation alone, I learned so much from you guys. So, oh man, this is amazing. I love it.
Likewise,
No,
likewise.
and wonderful. I'm so looking forward to having these weekly conversations with you guys and sharing them with everyone online. Everyone, don't forget to listen, share this podcast with your friends.
If you would like to help us to make even more podcasts and all sorts of different videos and educational content, you can head on over to patreon.com/Borderless Labs and become an everyday philanthropist for just $1 a month. We can do quite a bit with that, and there are so many things that we want to do. We want to be able to bring educational content to people in their native languages all over the world, to be able to get people excited about space, bring people together, and then start doing some really interesting projects, including building a CubeSat. You guys want to build a CubeSat? We don't need to be scientists or engineers to do that. We can do that. We have the technology and we have the knowledge. So let's get together and let's make something awesome happen.
Awesome. Actually, what inspired us to want to build this CubeSat project was one of the Google Lunar X Prize teams called Part-Time Scientists. Believe it. Was that their name?
Yep. German part-time scientists. Yeah.
So even though they didn't go to the moon, look, they just inspired us to do something and hopefully help humanity move forward. And that's what it's all about. It's all about we're doing this for humanity and hopefully helping everyone out with this educational content and hopefully in their own languages as well.
Well said. Yes.
Right.
And next time, we have a couple surprises for you guys. Not only are we space nerds, we love our cats. We all have space cats. Stay tuned. You're going to hear and hopefully see, if you are philanthropists, you will be able to see this podcast on our Patreon page and see the video feed. Otherwise, it's free for everybody else in audio everywhere you can download a podcast.
Awesome. Well, it's awesome to be here. Thank you for listening, everybody, and we will hopefully be able to catch you guys next time at Astra, which means to the stars.
Thank you, guys.
At Astra.
At Astra.